Ah, it will not. Oh my God. To watch it on Chrome.
So the whole point of the whole OAuth flow, going over to the authorization server, coming back to the client, the point of doing that whole kind of dance back and forth is to get something called an authorization grant. And the authorization grant is the thing that basically proves that the user has clicked yes, I consent to this level of permission, or I allow you to have permission to this stuff. I mentioned this a little bit before, but when the authorization server redirects back to the client application, kind of needs to know where to redirect back to. And that's sometimes called a callback, sometimes called a redirect URI. It's basically just where should I end up at the end of the flow? If the user clicks yes, where do they need to go next? And I mentioned how the authorization grant is kind of the point of this whole flow. Well, at an even higher level, the thing that the client really needs is something called an access token. An access token is going to be the key that they use to get into whatever the data that I granted access to or granted permission to on the resource. So as you'll see in a sec, the client will eventually get something called an access token, which lets them go do what they need to do. So let's go through this whole flow again and add some of these terms in bit by bit. So we're going to start on the client with me, the resource owner, probably sitting on the client website, and I click on that Connect with Google button. What happens is I get redirected over to this authorization server, which is accounts.google.com in this case, but it could be the Facebook authorization server, it could be an authorization server hosted by Okta, it could be somebody else. Right at the beginning of this flow, as the client is redirecting over to the authorization server, it's already passing along some information, some kind of configuration information that the authorization server. So it's saying, hey, when you're done, assuming everything is successful, here's where I want you to redirect back to at the end. So we have to pass that redirect URI at the very beginning. We also have to give it some other information, such as what type of authorization grant do we want? There's actually a few different types of authorization grants. I'll go into that a little later. In this case, we're going to use the most common kind of like simple example, which is what's called a code grant or the authorization code grant. Because we're requesting a code, this is sometimes called the authorization code flow. And at the end, as you'll see, we'll get a code. But I'm getting a little ahead of myself. So yeah, authorization server then prompts the user, log in, send to that level of permission, all that good stuff. Redirects back to the place specified at the beginning, redirect URI, and redirects back with something called an authorization code. That's what we asked for at the beginning. Now, the client actually can't do a whole lot with that authorization code. In fact, there's only one thing that the client can do at all with the authorization code, which is to go back to the authorization server one more time and say, hey, you just send me this authorization code. What I really want is an access token. I can't really do anything with this code, but I want an access token. Can I exchange this code for an access token? And the authorization server is going to say, sure, let me just make sure that code is still valid, isn't like forged, or you didn't make it up or something. Assuming that's the case, the authorization code is still good. The authorization server says, okay, client, here's your access token. And then finally, the client can do what they actually wanted to do in the first place, which is go to the resource server, maybe contacts.google.com, say, hey, I want to get to Nate's contacts. Now, normally, contacts.google.com would say, you can't have access to Nate's contacts. Who are you? But because the client is able to attach this access token to the request, then contacts.google.com is going to say, okay, normally I wouldn't let you have access to this information. However, you have this access token that proves that Nate said it's okay for you to access that. Here you go. Now, if the client tried to do something else, like maybe not retrieve my contacts, but like go delete all my contacts, hopefully contacts.google.com would say, okay, you have an access token, but it doesn't mean that you can do just anything. Nate said you have access to maybe read-only access to contacts. You can't go like delete them, or you can't go look at his location history and see where he's been or whatever. So this whole flow here, this is the whole thing. The entire rest of this talk, we're basically just going to be talking about slight variations or slight details of this flow, but this is the whole thing. So we're making some progress. I talked about how the access token basically grants access to the client to do a specific thing. But how does the client specify what thing it wants to do. Well, we need some way of being able to say, well, the client wants to do like read my contacts, but isn't trying to get access to delete my contacts. It wouldn't be very useful if it was like a black or white, all or nothing thing. We don't want to have like no permission or every permission. We want to have some way of being like very granular, have specific permissions that we can turn on or off or request. And to add a little bit more terminology to it, that is what OAuth calls this idea of scope or scopes. The way this works is the authorization server has a list of scopes that it understands. So it might be like contacts.read, contacts.write, email.read, email.delete, basically any type of permissions that make sense in the system. And then the client application, when they kick off this flow, they say, okay, I don't care about most of those scopes. I don't need to read this email or delete his search history or whatever. I just want the scope that gives me access just to read his contacts, and that's it. Or if they need to do more stuff, they could request multiple scopes, depending on whatever level of permission they need to have with my data. And then on the flip side of that, that list of scopes, that list of permissions that the client is asking for is then used by the authorization server to generate that screen, that consent screen that is presented to the user that says, hey, Yelp is asking for permission to do X, Y, Z, A, B, C. Are you sure you want to allow this? And the user is given the explicit ability to consent or not consent to that particular level of access or that particular list of scopes. In the case of Facebook, they changed their authorization server recently to be really explicit about letting you know whether or not app that you're giving access to is allowed to post to your wall. Because early on, it wasn't really clear. It was like, do you want to let this app connect to your account, yes or no? And if you click yes, you weren't really sure. Does that just mean they get my info, or does that mean they like get to span my wall? So because that was really annoying and people got really upset about that, Facebook made that much more explicit and granular. So you have to, if you're an application connecting to Facebook, if you're a client, you have to say, I do specifically want scope that lets me post to their wall or not. And then in the consent screen, it's made really clear to you, which is nice. So let's look at this diagram one more time. Not much changed here, except at the beginning, the initial request over to the authorization server, the client specifically enumerates all the scopes separated by spaces that they need to have against the user or for the user. In this case, let's say that the Yelp application just wants to access my public profile and my contacts. I'm simplifying it just a little bit here because Google scopes tend to be like really long URL strings, but this is the general idea. So what's going to happen here is, because the client requested scope, profile, and contacts, that's what's used to build this consent screen. And then after the whole flow completes and the client exchanges that authorization code for an access token and then uses that access token to go call some API, that access token itself is limited or scoped to exactly what scopes were requested at the beginning. So this access token, in other words, that comes out of this flow is specifically scoped to profile contacts. That's it. That means that the Yelp application couldn't turn around and send some other API request to like the Google Calendar API or a delete request to my contacts or whatever, because the access token, even though it's valid, is not scoped to do those particular things. All right. Any questions so far? We've gotten through quite a bit of the terminology. Great question. So the question was, why do we have these two things? Why do we have to get an authorization code and then exchange that for the access token? Why don't we just the code, or why don't we just get the access token immediately? Why is there that extra step? It's a great question. I swear I didn't plant you in the audience, but that sets me up perfectly for what I need to talk about next. So that's a great question. There's a specific reason why we need to do this extra step, why we get a code instead of just getting the token right away. I'm hinting at it here with some of these lines being solid and some of these lines being cached. But we need to talk about what it means to have a back channel and a front channel. So this isn't specifically OAuth terminology. This is more like network terminology. But we have this idea in networking of having a back channel, or what's considered a highly secure application channel, and a front channel, which is a secure but slightly less channel. I'll explain what I mean. So let's talk about a highly secure channel. Well, if I have my server code running on my server, only I have access to, and I make an API request or some HTTP request from my server to another server, like Google's API, for example, and that's going over, HTTPS. It's SSL encrypted. No one can intercept that communication. Highly secure. That would be considered what you would call a back channel, going from my backend server to some other API or some other system. A front channel, on the other hand, is something like your browser, where your browser is secure, but there's because of how browsers are built, what you would call a back channel, going from my backend server to some other API or some API, for example, and that's going over, request me a channel. I'll explain what I mean. So let's talk about a highly secure channel. Well, if I have my server code running on my, which only I have access to, and I make an API request or some HTTP request from my server to another server, like API, for example, and that's going over, HTTPS. It's SSL encrypted. No one can intercept that communication. Highly secure. That would be considered what you would call a back channel, going from my backend server to some other API or some other system. A front channel, on the other hand, is something like your browser, where your browser is secure, but there's because of how browsers are built, there's some loopholes or there's some places where stuff could leak from the browser. What I mean by that is, let's imagine that I'm building a website or I'm building a web application. I want to keep like a secret password or something in my web application. If I put it in the HTML or JavaScript of my web app, technically somebody could just right-click, view source, look through my raw code and see it there, right? If they really wanted to go digging. Or they could open up like the network console or the Chrome developer tools and see what my JavaScript is doing, change potentially what's happening on my page. So because of things like that, or simply my shoulder and see something that's on the page. Because of that, browsers are considered to be a front channel. In other words, we can trust the browser, but we only trust it as far as we can throw it, not complete trust. We have complete trust in the code that's running on our own server, but not complete trust in the browser. So as you'll see here, we're going to go through this flow one more time. As you'll see here, the way this flow is designed, including the reason why we have to get an authorization code and then exchange it for a token, is designed to take advantage of the best things about the front channel and the best things about the back channel, make sure it's highly secure. I'll explain what I mean. So let's say that we have a client going over to the authorization server. We've gone through this before. All of these things are happening on the front channel. What I mean by that is all of these are just full page redirects in the browser. We have on the outgoing request here, we have the redirect over to the authorization server, stuff that we're passing along to the authorization server, the redirect URI, what response type we want, all the scopes we want. Those are all being passed through the browser. This is usually just in the query parameters of the request. So technically, someone was looking over your shoulder. If you're looking at the address bar in your browser, you can see this stuff. It's not secret. But that turns out that's okay, because if somebody sees the scopes that we're asking for, who cares? If somebody sees what redirect URI we're going back to at the end, who cares? Because we're going to go there anyway. It's not like that's a secret. If you notice, coming back from the authorization server back to the client, that is also happening on the front channel. I've made all the front channel requests as solid lines here. That means that the authorization code is also transmitted through the browser, through the front channel. That means that that's usually also in the query parameters of the request. So if you really look, if you squint as the requests are happening in your browser, you can see the code in the query parameters of the address bar. So that means the authorization code comes back to the redirect URI, to the callback over the browser. The next step, though, happens on a back channel. So the reason we do it that way is because let's say that somebody was intercepting your browser requests, or maybe they had accidentally installed a malicious toolbar or something like that in your browser and it's watching your network. Well, someone who who could log network requests would be able to see the code as it came across the browser, because it's going to be /callback, $code equals something. Technically, they could maybe steal the code grab it themselves and then try to beat you to the exchange and try to get your access to it before you could, right? But it turns out they can't do that because the exchange happens only on the back channel. It doesn't happen on the front channel. So that token exchange happens when application, the client grabs that code and makes a back channel request from the backend server code back to the authorization server, but that does not happen through the browser. And again, that is for security. So we're posting, usually it's an HTTP post, we're posting that authorization code up to the authorization server, along with some other information like a secret key that only the server knows. So that means that even if someone stole the authorization code, they wouldn't be able to make that exchange request and try to grab your access to it before you could, because they don't have that secret key. And the reason this is on the back channel is because we don't ever want that secret key to be in the browser. Because if it was transmitted in the browser, we don't know if someone could have stolen it. So we do that only on the back channel, and we can trust basically our own server code. And the communication with the resource server using the access token is usually also done only on the back channel. Because once the application has an access token, the access token is typically considered to be like sensitive information. If I transmit the access token to the browser, someone could technically steal it. And then they would be able to do whatever they wanted with that access token, whatever it's scoped for, as much as they wanted. So that part is also done on the back channel. So I said at the beginning that this flow is designed to kind of take advantage of the best things about the front channel and the best things about the back channel. What I mean by that is the front channel here is used to interact with the user. So the browser is used to interact with the user. Login screen, present the consent screen, all that good stuff. That's what a browser is. But because we can't completely trust the browser with like secret keys and stuff like that, let the last step of the flow, the exchange, happen on the back channel where it's a system that we trust. Question? Yes. Yes, exactly. So the question was, does that mean that we had to do something initially set up with Google to get that secret and that key? Absolutely. So let's take a look now. We've looked at this diagram quite a bit. This is helpful to like understand how it works at a high level. Let's look at a little bit more like raw, how this actually works. And I'll definitely answer that question as well. So if you were to look at the link or the button that you click on that says like connect with Google or link to Google, this is actually where that's going to. This is what your browser gets redirected to. It's an address on the authorization server that you then pass a number of parameters to or some configuration. So I talked about some of these already, the redirect URI, what scopes you want, what response, something that you set up one time with the authorization server, with Google in this case. And then we usually pass along something called a state, which is just like a text value that gets sent over and then comes back at the end. But let me show you, I'm going to switch gears here for 1 second. I'm going to show you what it looks like to set up one of these. So let's say that I'm building the next Yelp, and I want to make this work. I want to be able to have people authorize their Google account so I can get access to it. What I would have to do is I would have to do a one-time setup step where I go into Google, I go to the authorization server, and I say, I'm going to create a client. And by creating a client, I get two things. I get something called client ID. It's actually this value that you see right here, kind of a long string, the whole thing. And I also get something called a client secret, which is shown here because it's a really like sensitive piece of data. So with that client ID and client secret, that is what identifies me to the authorization server. So the client ID is passed along with the initial request, which is on the front channel because the client ID is not sensitive. It just identifies the Yelp application. The client secret, on the other hand, is basically like my secret key. This is what I use in the back channel request during the token exchange step. And I'll show you how that works in just a sec. What I want to do is I want to show you how this looks in the real world. So let's say that I wanted to test this out. Because it can be pretty difficult to kind of get this working the first time because you have to make sure you have all the parameters set correctly and stuff. I'm not on Wi-Fi apparently. I created a tool called oauthdebugger.com, which just makes it a little bit here to test these things and see what's happening. Isn't working right now. Could be because I'm on the wrong Wi-Fi. Let's double check. Or it's because I'm giving a demo and the demo gods said, not today. Okay, so it's my Wi-Fi. Oh, cool. Try the Ethernet instead. Here's perfect. Thank you. It was the Wi-Fi. Thank you very much. So where was I? So I built a tool called OAuth Debugger. You can try it out at oauthdebugger.com. It basically just makes it easy to set up the request and then see if it worked. And then once you know it works, then you can take the debugger out of the loop for real application in there, and everything should work. So I'm just going to use this to demo what it looks like to make a request against Google and see what happens. So this basically just from Google, from the console. I'm going to request the scope profile. This gives me basic access to user's profile information. So far, which is response type code, meaning I'll get an authorization code back from the authorization server. And let's just give this a try, see what happens. It's going to ask me to log in. Notice my URL here is accounts.google.com, so we're over on the authorization. I'm going to log in. Since I logged in recently, I'm probably not going to ask my password. And okay, so we came back. This, because the redirect URI that I specified here temporarily was my debugging tool, it came back to my debugger, and you can see actually here, if you squint, you can see the authorization code here in the address bar. Or you can just see it right there. So this is the authorization code we got back from Google. Like I said, this isn't very useful except to the next step, which is to exchange it for an access. Can't do that through my tool here because that would require sharing your client secret with my tool, and you shouldn't do that with anybody, even if you trust me. But I'll show you what that next step looks like. Okay, so this is basically what we just did. If the user clicked no, I do not consent to this, or maybe you didn't set up the parameters correctly, something went wrong, you'll get the authorization redirect back to you error. But we did it all correctly, and I clicked yes, so we got back a code, what we asked for at the beginning. Now, the next step, like I said, is exchanging that code for an access. So what that would look like is a HTTP post to the authorization server on a different route called the token route. And basically, we just send along a request that has the code that we just got, our client ID, this time to include the client secret, which is that kind of really sensitive data, the secret only keep on the server. And then we just say, hey, authorization server, I just got this code, but I really want a token. Please give it to me. And assuming that code wasn't like made up or forged or something, that's exactly what you would get back. You would get back a response that says, here's your access token, good for this many seconds, maybe like 5 minutes or an hour or 5 hours or whatever makes sense. And then the client finally has what it wants, what it needs is an access token that can be used to make a request. So that request might look like this. Maybe we go call some other API or some other system, attach the HTTP authorization header to the request, say bearer, and then the access token itself. Because of that, sometimes access tokens are called bearer tokens. And all that's really doing is just saying, okay, the client's making a request to some system, to some API, including that token in the request. Then it's up to that downstream API to make sure the token is valid. They didn't just get this token, they didn't make it up. It hasn't expired, and it actually does have the scope to what they're trying. So if this request was like, delete contacts, hopefully that API was rejected even though the access was valid. But assuming all the checks, all the validations have been made, the request is approved, succeeds, and then the client holds on to that active. And if they need to make another request, they just attach it to the next request and going like that. So I mentioned that there are a couple of different OAuth flows, or a couple of different OAuth. Just been talking about this authorization code flow, or this authorization code grant type, where you get a code back. Why it's called that. And that uses both the front channel and the back channel together to kind of make a really highly secure changing this. There are some other ways to do it, though. There's something called the implicit flow. If for some reason you don't have a back channel, only have a front channel, then you can do what you mentioned earlier, is skip that exchange step. Just give me the token right back from the authorization. Don't give me a code. Give me the token instead. And that's used sometimes when you have situations, like I said, you don't have a back channel, only have a front channel. And that sometimes happens when, say, you have a pure JavaScript app, like a pure React or a pure Angular, has no backend. Maybe has some backend API that it's calling. It doesn't have a backend server that's actually like a page, has the ability to run some backend code. So in that case, if you have like a static single page app written in JavaScript, you don't have a back channel. So the only thing you could do is do this all in the front channel. I'll show you an example of that in just a sec, but I wanted to cover the other two flows that are sometimes. There's one called the resource owner password flow, or the resource owner password credentials flow. It's quite a mouthful. And there's something called the client credentials. Those two flows are back channel only. They don't involve the browser at all. This is basically just your code, your backend server code, posting a message to the authorization and saying, "Hey, I've got these credentials, just get access to them." They're not as commonly used as the first two. Client credentials flow is sometimes used for like machine communication, and the resource owner password flow is sometimes to like make older applications work correctly, but it's not the like recommended application. I can talk about that more if you want a little bit, but I want to show you an example of the implicit flow, which is in front channel only. If you don't have access to a back channel, what we have to do. Ideally, if we have a back channel, we can just back channel and use the authorization code flow, which is what you would do in most web apps and mobile apps. But if you're in like a single page app, you don't have access to that, what you do is, you'll notice all of these are solid lines. Go over to the authorization server. Instead of response type code, saying response type token means give me that access token immediately. Don't give me a code that I have to exchange. Which means that coming back from the authorization server, we just get the access token right away. We don't have to do that exchange step. And then you can go talk to a resource server with that access token, all entirely on the. So, like I mentioned before, this is considered to be a little bit less secure because you don't have that additional assurance that the exchange step happened on the back channel, have an assurance that the token is not exposed to the browser, because obviously the token is directly exposed to the browser. And that's okay if you're doing have a single page app. This is sometimes the only way to do it, and it can make sense in some situations. You just have to be aware of the security trade-offs you're making. You have to make sure that there's no way for the stolen from your app, which is just good security in general. All right, I think we have a question here. Oh, it looks like it was already answered. If you do have a question on the webcast, you can just enter it in and I'll get back to it. All right, so let's revisit our time machine, but we're going to fast forward a couple of years. We were in like 2006 or so. We looked at how the OAuth protocol was invented to solve the delegated authorization problem, where it's like basically exchanging permissions between systems across the internet. If we fast forward a couple of years, the OAuth 2.0 protocol got adopted like gangbusters. It was like very popular for solving this problem, which is awesome. A ton of people adopted it. It became like a really well-used standard on the internet. The problem was it became a like too used standard on the internet. It kind of became a victim of its own success in a way. It wasn't. People started to use it not just for the delegated authorization problem, but also for all these other use cases like mobile apps and just simple web login and sign-on and all this other stuff. Does anybody remember when the Facebook login button first came out? It was like 2009 maybe, but for the Facebook login button, the idea that you could log into a site with like just your Facebook or Google existing like social credentials wasn't a thing. It was kind of a new idea. I think it was like 2009. Well, if you look under the hood, the way that Facebook kind of built that new login with Facebook button, or Google built a login with Google button that's like kind of ubiquitous across the web now, is they just used OAuth. They just used OAuth under the hood because they said, hey, OAuth is really popular. It solves these use cases really well, and why don't we just use it for this authentication as well? So we end up in this situation where OAuth is being used for authorization, which it was originally built for, and also being used for all these authentication use cases as well. And unfortunately, OAuth was never designed to be for authentication. And I know that sounds kind of like maybe I'm splitting hairs. It's a bit of like an academic difference, but there's actually a big difference, and there's reasons why you shouldn't use OAuth for authentication. This happens to be why it tends to be so confusing to read about OAuth online, because if you just hit a random site talking about OAuth, half the time they're talking about using OAuth for authorization or permissions, originally what it was for. And half the time they're talking about using it for authentication, which, in my opinion, is a bit of a hack, not what the protocol is for. So let me explain why. Using OAuth for authentication is bad because in OAuth, there's no standard way of getting. So if you think about, let's say that I'm a website, you just logged in, I probably want to know at least a little bit of information about email address, name, login. That would be useful to have. Well, OAuth was designed for permission, scopes. It cares about like your access token scoped to a particular thing. It doesn't really care who you are. So there is no way in the OAuth protocol to get the user's information. So that means that when Facebook built the Facebook login button and built the Google login button and Twitter and Microsoft and LinkedIn, they built social login buttons and they used OAuth under the hood for it, they all had to add their own like kind of custom hacks on top of OAuth, make some way of being info and some other things that OAuth is just, which is again why it's sometimes so confusing to read about this online. All of these implementations ended up being just a little bit different. They're not really quite interoperable. This is bad. When we have a standard, we hopefully want it to be like super interoperable and same way. So because of this problem, because of the kind of OAuth being overused for this authentication use case, some really smart people kind of went back to the drawing board and they said, okay, OAuth works really well. It solves this delegated authorization problem really well. Now a bunch of people are using it for authentication. Not great. They're all doing their own weird hacks on top of it to make it work. Thanks, Google and Facebook. Why don't we try to add just a little bit, whatever OAuth is missing for that authentication use case, why don't we just add a little extension on top of OAuth to make it work for that authentication use case as well? Because it's pretty close, it's just not quite all the way there. So out of that effort came this protocol called OpenID Connect. And it's actually not even fair to call OpenID Connect a separate protocol. It's really just a 5–10% layer on top of OAuth 2.0 that says, hey, if you're using OAuth for these authentication use cases, just do this other extra stuff. That's it. So OpenID Connect isn't really new. It's just an extension to OAuth 2.0. Specifically, what OpenID Connect adds to OAuth 2.0 to solve these problems or kind of close the gap with its authentication use case is something called an ID token. And that ID token is exactly what it sounds like. It adds some of the user's information, the ID or information about the user. And if for some reason the ID token you get back from the authorization server doesn't have all of the information you want, you can also request more user information from the user info endpoint, all OpenID Connect, which all OpenID Connect authorization servers implement. So basically what this means is that if I'm talking to an authorization that understands OpenID Connect, not only do I get ask for an access token, but I can also ask for an ID. And that's literally basically the only difference between OAuth and OpenID Connect, or the only thing OpenID Connect adds. It adds some other really nice to have stuff like the way the spec is implemented is a little bit more standardized, and that's kind of nice stuff to make easier to use. But let's take a look at what it might look to do with OpenID Connect flow. This is going to look really, really familiar because it's that trying to drive the point home too many times. It's exactly the same thing. The only difference, if you squint and look really closely at the very beginning of the flow, notice how we're still asking for the profile scope, but now we're also asking another scope called OpenID. That is the only, like on the technical level, that's the only thing that means that this is an OpenID Connect request rather than an OAuth request. it is, and if you want to be really technical about it, it's both an OpenID Connect request and an OAuth request. We're just using OAuth, OpenID Connect. So what asking for that OpenID scope means that when we go over to the authorization server, all the normal stuff happens. We get asked to allow access to your profile or whatever. Get back to the callback with an authorization code. We use that code for an access token, but we also get back an ID token. So we get back both. And the ID token can be like immediately consumed by the application, understand or decoded by the application, and who the user is that just logged in. So we kind of closed the gap for doing authentication, not just authorization. And then the access token that we get back as the client application can then be used if we need more information about the user. Go then call the user info endpoint to get even more info about the user using that access token. So I want to give you a quick demo of this. I have an authorization server that is OpenID Connect compatible, running via Okta up in the cloud. So I'm going to use the other version of the tool I built called OpenID Connect Debugger to go ahead and try a request against that. If you notice, the only thing that, like I said, the only thing that identifies this as an OpenID Connect request is this OpenID scope. That's it. So I'm going to construct this request. I'm actually going to, instead of asking for code like I've been doing, I'm going to ask for an ID token. So this is actually the implicit flow in the sense that we are not going to get the code. We're going to get the token immediately back from the authorization. And I want to do that just so you can see what that ID token looks like. So when I redirect over to this authorization server that I built in Okta, I'm going to get asked to log in, ask a security question, and all right. So we get an ID token back because that's what we asked for at the beginning, and the ID token is this long string. It's actually very specific gibberish, but it looks like gibberish. The ID token is something called a JSON Web Token, or a JWT, sometimes pronounced as a JOT. And that's just a standard way of encoding a bunch of in a way that's transmitted. If I actually copy this ID token on here, and then go to a tool that can decode it, like JSONWebToken.io, paste that in here, and you can actually see what information is inside of this ID token. So it has a bunch of different properties. Basically, just a bunch of information about me, like my user ID, or email address, like that. Switch back to my slides here. Okay, so the ID token that you just saw kind of looks like this. I highlighted different segments or different chunks of that ID. But if you decode it, if you put it through the decoder that I just showed you, you get something that looks like this. There's a header portion, a payload portion, which is something called claims, and you get there's also a signature portion as well. The claims is what can be decoded by your application. Who just logged in, their information, when the token expires, when they logged in, all that good stuff. Kind of just based about the user. And then the signature is also really important because the signature can be used to verify that the ID token hasn't been modified or compromised or rather changed in a way. Like, so the client application can actually take that signature, do some crypto math on it, and say, okay, I know that this ID token has been stamped by this authorization server, still authentic, it hasn't been modified, they didn't go in and try to edit somebody else or whatever. So that's a really cool feature, the JSON Web Token standard. Header, payloads, claim, and signature. So like I said, the ID token, because of that signature, it can be kind of independently verified by the application without even necessarily having to go back and talk to the authorization server. Also, like I mentioned before, I could use the access token I get back to go call that user info endpoint. If the information in the ID token wasn't quite everything I know about the user, go to call the user info endpoint, say, hey, I want information about this user. Here's the access token that proves I'm allowed to have this user's info. Get even more info about the user. Sometimes it's like additional stuff like their profile picture, things like that. All right, so let's revisit our time machine one more time. Now we're all the way fast forwarded. We have OAuth 2.0 still being used for those delegated permissions. That's correct. And now we're also using the correct tool authenticate you too. So mobile apps for single sign-on or for some like simple login case, OpenID Connect, instead of misusing OAuth 2.0 for that stuff. And just to be a little bit even more specific, we would use OAuth whenever we're dealing with permissions and authorization, OpenID Connect whenever we're dealing with authentication. Sometimes some people get confused and think that because OpenID Connect is like newer, then it replaces OAuth 2.0 or it's better than or whatever, but it's not like that at all. They're different tools for different jobs. The only thing that OpenID Connect replaces is misusing OAuth for authentication. Definitely not do that anymore. But for still doing like permissions and delegated authorization, OAuth 2.0 is the right tool for the job. All right, so let's take a look at a couple of like practical examples. We're almost out of time here. I want to show a couple of practical examples of like what OAuth flows or OpenID Connect flows to use for particular use, because this tends to come up a lot. Some complexity in the spec about like what flow is used, what situation and stuff like that. But I'm just going to really briefly go through some of these. So let's imagine that we have a really like a basic web application we want users to be able to log in. This is kind of revisiting that simple login code right at the beginning. At the very beginning, we talked about a simple website that just had like a form with an email and password field, hitting the database or some info. If we re-implemented that with OpenID Connect, what we would do is the authorization flow. So go over to an authorization server, maybe run by Google, maybe by Okta, maybe one that you made yourself or whatever. But use the authorization server to handle the login stuff. And all the application needs to worry about is knows it's going to get an access token, ID token back from the authorization. And then just like at the very beginning example, probably going to just drop like a section or a session into the browser to keep track of the user. Then on the back end, it's just hold on to the user's access token and ID token while they're logged in. The benefit that this has over forms authentication at the very beginning is that now the authentication system and the rest of the app are kind of a little abstracted. They have a little bit of separation. What makes that nice is that then the app and authentication system can kind of evolve separately. You can do maintenance on the authentication system and update it if stuff needs to change, controls need to be closed, all that good stuff. OpenID Connect is just kind of the glue that keeps them tied together in a standard protocol way. It's really nice. This looks almost identical for native mobile apps. You have a native app on iOS. This one, technically that too. You would do the same exact thing. The OpenID Connect authorization code plus one extra more little extension called PKCE, Proof Code for Key Exchange, called PKCE, to just do the same thing. Get an access token, get an ID token, save those on the device, or them behind the keychain or behind Touch ID. Use the ID token to understand who the user is, an access token to authorize API calls, all that. What's really, really nice about mobile is that all of the stuff involving going to talk to the authorization for making sure the right flow, making sure you PKCE, sure that you do directly on different, like, there's some differences between different mobile operating, like on a specific cat browser control, or maybe now something like that. On iOS, you have to use RSU controller, all that stuff is all abstracted away in this library that folks worked on called AppAuth. You basically just use AppAuth and it's all good. The other example I talked about was a single page app with an API backend. This is the situation where you don't have a back channel implicit flow. Otherwise, it's identical. Things back from the server, storing those in your app somehow, taking some care to make sure that you don't to make sure that those tokens can't be leaked in any way. So you need to make sure you're not going to have any XSS in your JavaScript and stuff, but that's a little bit outside of the scope of this talk. There's also some other cool stuff you can do. This is also outside of the scope of this talk, but you can like you can use a authorization server like Okta to provide a bridge older protocols like SAML or other things that you don't really want to deal with in your app. Your app only has to focus on OpenID Connect, and then let the authorization server handle all the work of dealing with a protocol like SAML, which is kind of cool. But that's all I have for today. If you have any questions, I'm happy to answer them. Otherwise, you're free to take off. I've got a couple more resources for you. If you want to dig even further into how these protocols work, especially how OAuth works, hit up oauth.com. We have a free ebook that we've published there that goes into like a ton of detail about how it works. Even I got into today. It talks about stuff like token, like expert validation, all that stuff that I didn't really have to go into. And if you just want to play around with it, if you want to spin up your own authorization server in the cloud, totally free. You can go to developer.okta.com, register for an account, create as many authorization servers as you want, play around with them for totally free. Super easy, super cool. So thank you so much for your time. I'll leave it open for a couple more questions, but otherwise, have a great day.
Hello everyone, my name is Carla and I'm a senior
Carla! My name is Carla. उठवत का नाही रोज सकाळी फोन करून Ah,
तर कारण काय असतं मी रात्री अभ्यास केला, जागी होते.
ah.
माझं बाबून कावर गेलता आता तू?
पडल का? हा?
पडलं पण.
गाडीचा